I'd like to explain compass bearings and also true bearings. We need to understand both in this course. Now, take what you already know about compass bearings. North, south, east and west, that's something you should be pretty familiar with. These are pretty handy if you just want to give someone a basic description of where to go. But if it's not on one of these exact cardinal points, we also get used to using a number of other terms. Dividing these up into half gives us northeast, northwest, southwest and southeast. And for those of you who've done a little bit of orienteering, perhaps you enjoy to break these up a little bit further. And we've got plenty of cardinal points here that we can name. Now, naming these in between ones might seem a little bit tricky, but if we've got halfway between north, east and east, take which one's more important. The purple one here, east, label that first, and we have east, northeast, north, northeast, etc., north, northwest. Now, I'm not going to label all of those. I've done these in red on purpose because we're not going to use them, but you may already have an understanding of them, so I want to start with that. Now, the reason we're not going to use these red compass points is because, as you can imagine, they involve splitting 90 degrees in half, 45, splitting that in half, 22.5 degrees, splitting that in half, 11 and a quarter degrees, and so on. So if you've got a measurement that you want to explain as a compass bearing and it's not right on one of those, you could get into all sorts of hurt trying to describe north, east, east, north. It'd just get really complicated. So we're going to rub out those red ones and start again and explain how we do use compass bearings when we're doing a mathematical problem. We still want north, south, east and west because they're the important ones. But any line that's somewhere in between, we're going to describe it as though we've measured it with a protractor. So, for example, if we have a compass bearing out here and we know that this is 70 degrees, then the way that we name it, we start always with either north or south. So this is compass bearings, start with N or S, and then add the degrees that it has deviated away from north or south. So add degrees of deviation, and then add the direction. Now, how far could it have deviated, or which way could it have gone from north or south? It could only have gone to the east or the west. So it will end with an east or west. So to give you an example, this line here, it's closest to north, isn't it, than south? So it starts with the north, and it's 70 degrees towards the east. Okay, that's how you label that one. That's the compass point of that. And we put the degrees in there, north, 70 degrees, east. So if you had a point like this one, say, where it's 20 degrees down here, this is closer to south than it is to north. So we'd label this one south, 20 degrees. Now it's going towards the west, isn't it? So it's south, 20 degrees west. And in fact, we could have one up here that would be really similar to this one. If that was 70 degrees, then we'd say this one is north, because it's closer to north than south. And it's deviated 70 degrees towards west. So these are quite straightforward. Now when you get one in a question that says maybe a ship sails on a bearing, and then they might describe the bearing, south 20 degrees west, say, from P to Q, your first thing that you need to do is draw that. So draw P, and then say, what is south 20 degrees west? And you need to be able to picture that south that's gone west a bit, 20 degrees. So it's an angle something like that, and now you've got P and Q, and you know what this angle is, 20 degrees off dead south. So that's how you sort of use these to label compass bearings. Now, true bearings are a little bit different. You'll need to get this down, just pause the video if you need to. True bearings don't use south or west or any of those points as a marker. They just start completely from north. So true bearings are all based on north. So let's say they start at north, and that's called 0, 0, 0 degrees, T. We'll explain that in a moment. True bearings all have 3 digits, and they describe, let's say, a deviation clockwise from north. So they all have 3 digits, even the small angles. They describe the deviation clockwise from north. Now, what about this little t here that I added? This is sort of optional, but if you're wondering what it is, T is for true, because these are true bearings. So you can put a T on the end to show that you've given it as a true bearing, so that people aren't confused and think that you're giving it as a compass bearing and wonder where your north and east and those other letters might be. So that's what the T means. It's a true bearing. So let's look at some examples. Let's put in a line up here that might be, let's say, 35 degrees here. Now the way to label this is to say that north is 0, 0, 0 degrees T. So we've moved clockwise how far? 35 degrees. Now to make that a 3-digit figure, 035 degrees. So as you can imagine, these numbers go up and up and up and up until we get to 359 and a bit degrees, and we never get to 360, that's back to 0 again. So let's have a look at a few more examples. If we had one down here that is, let's say we know that this is 20 degrees, and we're asked what this true bearing is. Well, we can use this 20, but we need to use it and think through, hold on, how far have we come from north to get around that far? Well, this is a straight line, so that's 180 degrees. So if we've gone all but 20 of the degrees out of the 180, we must have travelled around 160. So this line will be, this bearing would be called 160 degrees T. Due south will be 180 degrees T. Obviously we've got 090 over here at east, and 270 degrees T over here at west. And let's do one up here in this quadrant. Let's say we know this angle here is 40 degrees and we're asked what this bearing is. Well, we've gone almost 360 degrees around, but just 40 less than that. So this will be 320 degrees T. Now, if it's a fraction of a degree, don't forget the degree could be broken up into minutes and seconds in the usual way with the dash and then the 2 dashes.